Hello again, everyone. Got about a minute here, but before we'll get rolling, I want to make sure that, again, my microphone's on and everyone can hear me okay, and we'll get started here in just a minute. All right. I'll welcome everyone for joining us again today. If you missed us yesterday, we're on day 2 of our statistical webinar series here, ARM and statistics. A couple of housekeeping items, just kind of the same as yesterday. Kind of buys a little time for anyone who might be joining still here. We are recording this session, so we'll be able to post that out to our website when we're all done here. We had great reception for this meeting, and our platform's limited to 100 people, so we actually had people registering that couldn't join us. So we want to make sure that this is recorded and can share with everyone, and anyone who is connected today, you can also have that for future reference. So out on our website, gdmdata.com, you'll be able to find these. Under the resources heading, we have our webinars page. And we've got our upcoming webinars listed, and underneath that are the archives. And here I've got my section, and you can actually see the link to yesterday's session, kind of give a broad overview of the topics, and we're diving into the specifics within the software the next three days that we have here. So. All right, my other note here is to encourage the use of the chat. It looks like Simon's in there already, so he knows right where that's at. That's a great place for questions. So as we're going along, today we'll be in the software a bunch more. So I would expect maybe more questions as we're moving along. Something, if I move a little too quickly and you missed how to get there, or have a question about what we're seeing on the screen at that time, feel free to throw that question in. I'll try to make sure that I catch that before we get too far after that. And then we'll also have some time at the end as well for any questions too. So the chat works great. So that way, if people send in a question at the same time, that works just fine. We can just run down the list. So feel free to use that chat, and we'll get rolling. So yesterday we went through an overview of kind of the whole gamut of the statistical topics, really at basic level. And one of the first topics we approached was the fact that you can't quite dive into the analysis as soon as you put in the numbers. That was a kind of an important distinction that we wanted to make here, that once you get into ARM and put in the data, you're not quite ready to just hit run and see a report and start crunching the numbers. Instead, you really need to look over that assessment and the values that you have before you start that analysis process. Really, the big hitting item was the fact that outliers, rogue values, they can happen, but those values really mess up the analysis. We talked about the assumptions of AOV quite a bit, and really an outlier can break just about all of those assumptions. If it's present there. And so that really can cause some troubles in the analysis step. And so it's really best to look over those numbers that you've put in. And so I'm kind of calling it data confirmation. It's kind of the step. I kind of wanted to separate it from a more general term of data review. I think there's really 2 different steps within that, looking at the data before you actually start chugging away with an actual analysis. And so today I kind of want to focus on that. Okay, as I'm entering the data, as I'm taking the data, what should I look at to make sure these numbers are right and then what they should be? And then the next step is the data review in the sense of, okay, do these fit the assumptions of ANOVA? Do we need to perform data corrections? You know, what do we need to do to prepare ourselves to know what analysis we're going to get? And then that's kind of that final third step is the results, you know, and talking about what you get in the results. So that's kind of the progression that we're looking at in this training. And so step number one is data confirmation when you're recording the data, when you're putting it in. And so, oops. So as promised, not going to spend much time in PowerPoint. We're going to spend most of our time here in ARM. And so I just have a trial open. It's just kind of an example trial that I've used in some tutorial videos. And I just have a data column here that already has information filled in. That's kind of the where we begin with that data confirmation step, is that we recorded data for an assessment. Just my example here is that we are doing a area of disease here on your leaf, and we had 5 subsamples. So we took 5 different leaves and wanted to rate the disease present here. So we want to kind of begin with just the numbers here. So we've already entered in the values, and really the first place I go to then is on the properties panel. On the right-hand side of the editor, there's a section labeled tools. And so I actually work from the bottom up actually, and really the first one that I go to is the assessment map. So when I click on this button, it's going to draw my trial map that you have configured for the trial, but it's going to draw it with a different color set. And so these colors correspond to the data values in your plots. And so we take the range of values, in this case it's from 0 to 120, and split them up into 10 sections or up to 10 sections and draw this heat map of the values that are in this data column and put that onto the trial map. And so really the benefit here now is you get a spatial look at the values that you recorded. So it's a little hard to visualize certain things just by looking at the list of numbers, but here then on a map, you actually get that spatial component. One of the first things to do is in the options tab, you'll want to make sure to have the show true scale option on. So if I toggle that off, I'll show you what it looks like otherwise. So here, without that true scale, it really just shows the randomization essentially. So each plot is just a square, so we can kind of show you know, how the randomization is. But using the show true scale then draws each of the plot rectangles according to the plot dimensions in the trial, and then some of the spacing if you have alley widths and things like that that you can specify in the trial settings. All of that gets drawn to scale. So it really gives you a better sense of exactly what the spacing is in real life. So here we have our trial map with all of the colors here highlighted. And if you want to click on a given plot, this will actually show then all of the treatment 3 in each of the replicates. So you can kind of inspect just a given treatment number to see how consistent it was across the different replicates. You know, so 3 pretty light in each one of them. It looks like this replicate might be a little bit heavier than the others. And you can just simply click into the different treatment numbers on any plot, and this will switch then to show just those, just that treatment number throughout the plot. throughout the field, I should say. And that option is this checkbox over here, color by current treatment. So if you want to take that off and view the whole screen again, just clear that checkbox. So as we look at this map, there is one value that is exceptionally dark. And so that might be a good indication that we should inspect that value. And even looking at the treatment 4, definitely most of the reps are pretty consistent, but it definitely is very strange here, that plot 904. So that can be a good indication of a value that we should go and look at to make sure we typed in right or there wasn't some sort of problem. But I'll actually show the next tool as well. It's kind of a planted problem plot here, and we'll show kind of how a problem plot will show up in the next tool as well. So if I close this, the next tool to show is right above that assessment map. It's the box Whisker. And so here, the box Whisker graph, this will, again, be graphing just this one data column that we're looking at. And so for each treatment in our study, then we'll draw a box Whisker graph of the data. And so if you're not familiar with the box Whisker graph, what it does is it'll take the data values for that given treatment, and it will draw the 25th and 75th percentile, and that creates the box. So kind of 50% of the data range that you have is contained in that box from the 25th to the 75th percentile. And then the whiskers extend to all of the other data points outside of that middle that are not outliers. So an outlier is a value that is more than 1.5 times the height of this box away. So if we look at treatment 4 here, there's an X way up here, and that is an outlier. Not surprisingly, it's that 904 that we saw before was a very extreme value. And so the whiskers, maybe a treatment 5 here, there's also an outlier right here, the plot 203. If you hover over that X, ARM will draw and kind of tell you actually what plot that is. So looking again at these boxes here, the waste, so this kind of sinks in to kind of give you a waste. And the waste is kind of a way to gauge the skewness in that treatment. So if we look at treatment number 4, you can see that the waste is a lot higher. It's not right smack dab in the middle, it's a lot higher. And so that indicates that there be skewness here. And obviously with that very large value, that's most likely the cause of that. The circle is your mean, and the waste is the median. So if you're very balanced data, of course, those all about line up and match, and that's the case in most of these. But you'll notice these last two that have the presence of outliers also have definitely a mismatched waste. So the median and the mean are not lining up to be the same, not because of those extreme values that are pulling up the mean, whereas the median isn't as affected by an extreme value. So now we've got 2 really good reasons to go check out plot 904. So if we close this, we can come look at plot 904. And the question here about the outliers. Yeah, we'll kind of talk about, so the one question here, if we have an outlier, should we avoid it in the calculation or what should we do with it? So we'll kind of talk through the different options here soon. And just wanted to bring up that box Whisker one more time because there might also be an X above the tub 1, yes, so that's a good catch. There is actually 3 outliers. I had not noticed that as we went past, but there is actually an outlier here. Plot 705 as well is an outlier. So that's a good catch. We really do have 3 of them. And it's a little less obvious, but actually I think that waste is markedly below that mean, just not quite as substantial of a difference as these other 2 that drew my eyes in. But that's a good catch. There are actually kind of 3 of them here that should be under consideration. So looking at plot 904, then, you know, here's kind of just the thought process of looking at the data now. We should take a look at these outliers and see what's going on. In this case, we have a value of 120. While considering this assessment as a percent of area, we know 120 is absolutely invalid. There's no such thing as more than 100% of the leaf that could be covered in a disease. So we know that this value is wrong. So then it comes to kind of how you collected the data as to well, what to do next. If we collected the data and wrote it all down on a piece of paper, well, maybe this is a simple transcription error. You know, we can grab that piece of paper and double check, you know, 904. Oh, yep, that was just 20. I was supposed to type in just 20 and I'm good to go. But maybe that's not quite so clear. Maybe 120 is what was written down. Maybe it was typed in or whatever, and we're a little less certain. You know, looking at the value, it could be a 12, it could be a 20, it could be a 10. You know, all of those are just as likely as far as if you were just typing those in, if you don't have kind of a record of that value. So it's kind of depends on how certain you can be with that data point. And that's kind of one of the advantages of if you can get ARM into the field, and if you're noticing this value while you're still taking the data, then you could go and look back at that plot. And once you've left the field and you have left for the day, there's really not much more you can do then if that value is ambiguous. You don't really know what was going on. You can't go back and recount or anything like that to get that value back. So you really want to be careful with you know, when you're taking that data, and it's kind of an advantage for the tablet data collector getting the software in the field so you can use some of these tools and do this data confirmation step while you're in the field. So you won't lose those values. But, you know, so really the worst case scenario then is, you know, I don't know what to do with this 120. It's definitely not right. You know, in this case, we know it's unequivocally not valid because we can't have that. So we have to throw it out. And so to do that, in the assessment section here on your properties panel, there's a damaged marker. So what this will do, if I click out of the cell, it draws a red strike through that value. And essentially what happens now is when we go to do the analysis, this plot 904 will be considered just a blank, a missing value. Only in the analysis. Of course, we still have this number that we can do something, you know, that we have recorded, but we're saying that it's damaged, it's not able to be included in the analysis. It's not valid to do so. And we'll kind of come back to a little bit of the various options on when your data, you're not totally certain if it's valid or not. So this case is pretty cut and dried. You know, 120 absolutely can't be right. And so let's say for a little simpler example, instead of tossing it out, we can look on our piece of paper and say, yep, this is 20. I wrote down 20, so I know the value is 20, and it was a simple transcription error. So as long as you can be very confident in changing that value, we will do so. But you have to of course be very careful. You won't want to change it and take a guess. Obviously it's not 120, but it probably was 20. Is really not good enough. You need to be certain of that. Otherwise, you'd want to use that damage to kind of toss toss it off. Good question here. If it's marked as damaged, that will impact your tools here. So if we look at the assessment map, I had marked it damaged. Now you'll notice that that value gets whited out in this case, and the rest of the map is drawn accordingly. So now the maximum value is only a 65. Now actually there's a lot more interesting things going on here now on that map. And the same thing for the box whisker as well. So now we don't have that extreme value at all, and our box whisker is looking a little nicer. So here, for our example here, we'll say that this 120, we do have written proof. It's actually a 20. That's fine. I know for a fact it is. So I'm going to chalk that up to a transcription error, and we can correct it. So just like we had shown here, now we can see on the assessment map, this map is actually maybe a little bit more interesting now because we got rid of that really high value that was changing everything, and now there's actually a little bit more detail going on here. We have a little bit more difference in these values. You can kind of start to see if there's some sort of site effect. And that's kind of one of the advantages of this is you can tell if maybe the whole left half of the trial is kind of a gradient of a lot darker values, and then it slowly tapers off, and then it's lighter values on the right-hand side. Well, now there's a gradient involved, and we certainly want to make sure that our blocking actually account for that or not. Maybe there's a really dark area or maybe a really light area in the middle of the trial, and that was because there was a irrigation line burst or something like that. Things like that it's a little bit hard to see a pattern just in the list of numbers. Really, that assessment map is very helpful for that. We had also mentioned yesterday a good example, because that kind of helps some of those assumptions of AOV that are a little harder to test statistically. So we had said let me just bring up that slide since we're talking about it here, the independence of errors and the additivity. We don't have kind of cut and dried tests, statistical tests like we do for a couple of these other issues. That heat map is really a good way to catch some of those things. Seeing that edge effect that might be taking place, stuff like that. You can at least detect that here with the assessment map. All right. So those are two tools. The box whisker and the assessment map kind of help us to find some of those strange values, some side effects. One other tool that we have on the right-hand side, there's a column diagnostics panel. And I'm going to click on that, and then I'm going to press this little pin button to make this stay on the screen. Actually, I'm going to unpin my properties panel so that way I have a little bit more room on the screen. So this diagnostics panel is quite new. We've added just in a few versions ago, and we're kind of adding more tools to it. It's going to be a big focus of ours in our next section with the data review, but there's some pieces here that we can use just in this process of data confirmation. And so in this diagnostics section up on top, there's some descriptive statistics. I have a better term for them. Really just some stats on these numbers. So not really an analysis of the data as much as just here the number of data points that we have, the number of unique data points in the column, the number that are analyzed, and then you can see how many plots are missing, how many are empty, how many have been marked as damaged. So that example where we had marked this as damaged, then you'll see that gets highlighted there. So it provides kind of a nice summary of what we're looking at in this data, especially if you have a lot of data values. It might not be super evident, some of those things. And I kind of want to point out the difference here between missing, empty, and damaged. So we mentioned how this will, using the damaged flag, let you drop the value from the analysis. So it kind of acts like it's a missing value and isn't included in any of that, but you still get to have a place to record the number. If you simply didn't have a number to record for this plot, then you can use a period. And so when you do that, that is a missing data point. So it'll be treated, these two will be treated the same when it comes to the analysis. The 20 will be tossed out and it'll be treated like there's nothing there. Same thing with this period. It'll be treated like nothing's there and that plot 905 doesn't have a value. The important thing with that period though is then to distinguish from a blank cell. So a blank cell also, there's no number there. So with the analysis, it's still going to be treated like there's nothing there, of course. But the difference between these two is intent. So someone else that might be reviewing the data, or even yourself a week or two later, if you're as forgetful as I am, would come back and look at this plot 1001 and say, okay, did I not have anything to record here? Or did I just accidentally skip over it? And so having a blank cell really isn't very good to do. It's ambiguous whether you just forgot it. I actually have a value somewhere and I should go find my data collection sheet, or there wasn't anything there. And so you want to use that period to declare a missing value to say, yep, I know there's no value here. I want to confirm that there's no value to do, as opposed to just, I overlooked this cell. Yep, and so related to this, so whether it's a blank cell, whether you put a period, or the damaged flag, all three of them will be treated the same in the analysis. So Dan, you mentioned that Yates formula. There is the Yates, and I think there's also the average, or kind of the two data estimation options that you have for kind of correcting for that missing data. And so all of those will be treated the same. So it'll use Yates, or it'll use the average, or if you're using the least square, I don't think you even need a missing data correction there. But the behavior in ARM will be the same if it's blank or if it's a period. Really, that's the only difference is the intent to declare that you mean for it to be blank, essentially. And that's why you'd want to use that period. So if I click away and come back in here, we can see the updated total. So there's a missing data, that's the period. There's the empty, which is empty and doesn't have any value in it. And then there's one that's marked as damaged. So that's a nice way when you begin to look at the data to see. Hopefully you're seeing nothing in the empty. You know, that's a good cue that I need to look up to see, okay, what one's empty, and I need to make sure if I should make that a missing value, or if I should find my value to fill in. So if I were to say, yep, it is still missing, but I don't want it empty. Now if I do that and refresh here, now there's two missing data points and none of them are empty. All right, I'm just going to undo all of my little tweaks to get my data back. Okay. So those first few rows, those are helpful to kind of get an overview of the data. If you scroll down, you'll see a lot of statistics, and that's what we'll dive into in our next session, really more for that data review, preparing for the analysis. The other thing you would want to look for on this panel is the outliers section. And so this would display at the bottom. There's not a guarantee that it will display. So if you're in a column of data and you don't see that section, that means there are no outliers that are calculated. Here in this section, the outliers does display, and plot 203 is calculated as an outlier. And you'll note part of why we didn't have that other one is we have changed 904 to kind of a regular value. And so then this has refreshed to take that into account. So if I click on that row here, then ARM will take me right to that plot 203, and we can take a look at the number. And so this outliers calculation is actually different from what we had on that box Whisker. So if you recall here, maybe let's pop open that box Whisker with the new information. So we do have plot 705 and plot 203 are two that have been flagged as potential outliers for the box Whisker. Be here on this panel, we actually just have plot 203. And so there's a few different ways that outliers can be calculated. This one here on the diagnostics panel is pretty conservative in the fact that it won't flag too many values as outliers. So it uses a standardized residual is kind of the calculation basis that it uses to determine if a value should be considered an outlier. And that you can actually find in this table up here. There's this max standard residual. So each data point here would get a standardized residual, really taking into account how many assessment values you have in the column. So thinking of normally, perfectly normally distributed data set, if you had 100 data values, just to kind of cheat the numbers, then if you were to use plus or minus 3 standard deviations as your way of calculating outliers, a perfectly normally distributed data set would still have is it 1.5, round up to like two outliers according to that even. And so this calculation here on the diagnostics panel tries to account for that and kind of standardize that to really weed out any of those institutional outliers, for lack of a better phrase. I think without a fantastic statistical background, I can't say this is more of an opinion than a fact. I would think in the data confirmation step here, you would be more interested in finding any potential outliers. So this calculation here might not be the optimal one for data confirmation. It might not be a bad idea to use that box Whisker to look at both of those plots. So in this case, essentially this tool says we should really only check out plot 203 and see if this value is strange or incorrect in some way. Whereas looking at the box Whisker, again, we had plot 203 we should look at again. So both of them agree that that one is odd, but the box Whisker also says check out 705. And really with this data confirmation step, it probably doesn't hurt to look at that number, both of those numbers and see is there something strange with that value. And so that would actually bring me over to the third pane, the third panel that we have here in the editor, the column properties. So these are a little bit disjointed. I kind of would like to see in the future, maybe we combine this a little bit better or move things around a bit. This column diagnostics is quite new and again, kind of focused on the data review portion, kind of preparing for the analysis. Column properties kind of has a little bit of both to it. So if I take off my diagnostics, the column properties actually does have a different outliers calculator as well. So here on that column properties, we also get kind of just a snapshot of some information I don't know that this is particularly relevant to us though right now. Some of these statistical information here really isn't too important for the data confirmation step, but you can use this outliers calculation, and here you can kind of choose some of those other methods for determining if a value is an outlier. And again, so you have that box whisker. So this is that same calculation that's used on the graph. You take that 1.5 times your box height for each treatment. And if a value falls outside of that range, then it's considered an outlier. Whereas you can use the standard deviation as well. So here from the grand mean of the column, if a value is more or less than 3 standard deviations from that grand mean, it would be considered an outlier, or plus or minus 2. And so when you choose one of these options, then you press the Find Next button, and it'll bring you right to that plot. So here again, plot 203. If we press Find Next again, it doesn't move. So that means that's the only outlier flagged here with that calculation. Box whisker, we should find 2 of them. No, surprisingly, it's only bringing me to 203. Let me double check our box whisker graph. Oh, it's interesting. It's not finding our 705. Oops. Let me get my panel back here. We don't have anything marked as damaged. I'm not sure why that it's only finding that, so I guess I'll have to kind of play around with that to see what I did different there. The box whisker outliers calculation. Well, we made about 1.5 hours into our statistical presentation before I found one thing that's not lining up, so I'm doing okay. But it's really that Find Next button will be grayed out if there is no other calculation there. So if I were to, let's just mark this as damaged real quickly, or actually I could just do a period as well, just to take that out. And to refresh, you'll notice these kind of all gray out when you change a value in the column. So I usually just click into a different column and then come back. There was a question a little bit ago. Also works on the diagnostics tab. So as soon as you change something in that data, we need to recalculate everything. And so instead of recalculating every time, if you're like entering data or something, that would take forever if it's constantly recalculating. So you just kind of go from one column and back to the other, and it'll refresh and recalculate. And so here now you'll see the Find Next is grayed out because there is no other outlier calculated. Here with the standard deviations now there is, now that we've thrown that value out. So that's kind of your cue that there isn't any other outlier. So if I undo that and come back and now looking at once you've used the tool to find that value, there was that question before about kind of what to do with it. So our first example of 120, we knew that's wrong. There's absolutely no way that could be the right value. And so we could be confident in changing the value, or maybe we had to throw it out because there was no proof of what it really could be. Something like this though, we have a 65. Well, that's perfectly valid. That's a valid percentage. There's no reason 65 couldn't be true. And so that's where just because it's an outlier doesn't mean you should throw it out. I think you would need some sort of proof that something bad happened. Something that the plot was clearly affected by some outside force, if there was animal damage in the plot, or we said before, an irrigation leak and messed up several different plots, something like that occurred, then, it's really valid to throw this value out. That's not a typical scenario. That's not one we're trying to test. And so let's toss that value out from consideration. There is some statistical ramifications from dropping out values. So you don't want to do that too liberally. You really want to be careful. For each data value that you toss out, whether it's marking it as damaged or if you don't have that value and it has to be missing, you lose a degree of freedom. And so the power of your statistical tests when we get to that analysis step is going to be reduced with some of those things that get thrown out. And so really, you want to take care with that, to not throw out too many things just because the value doesn't seem right. You're going to lose some power with that. But of course, if there really was something that went wrong, then you should throw those values out. So typically, kind of the end line I like to point out with that really is that unusual data, like this case, the 65 is pretty unusual, but that doesn't always mean it's damaged data or data that you should throw out. So in fact, maybe that's incredibly important that the 65 occurred. That this strange thing happened in this situation, and that data really needs to be included. It kind of I don't remember where I had read it, but they kind of compared the outlier to say that not all outliers are bad. Some of them might even be Michael Jordan. That actually might be the most important data point that you recorded in this whole assessment because of what happened there. So you don't want to just toss them all out just because it's considered an outlier. And that's really where you want to make sure you take a lot of notes. Another kind of shameless plug for that TDC is if you see this 65 and you're still in the field, then you can go over and you can, number one, confirm the 65. Yep, I took that right. It is 65 in this case. You can take a picture. There's a spot in ARM to record a comment of the information. If you had additional comments you wanted to make to say, yep, this strange thing happened, you can take a picture and attach it to that plot to provide all this documentation. Because chances are somebody else looking at the trial might do the same thing. Wow, this is a very strange value. But instead of just saying, well, we should toss it out because that's weird, instead they can look to see that you have this comment, you've confirmed all this information, there's a picture to prove it, and now you have all this additional documentation and information about what actually happened. So that's really all the main focus of this data confirmation is to make sure that your values are valid. Not that they're normal. Certainly outliers can happen and maybe should be in there. You just want to make sure that you recorded it correctly. If you're transcribing from values written down, that you didn't make an error there, making sure that data is accurate. That's really one of the strengths to ARM is being able to document all of that information if something strange did happen. So just real quick, because I know it's a little bit of a confusing point, and maybe even in the future we'll try to combine and simplify that. But there are, just to recap that, outliers. There's two different spots where you can calculate outliers. And here, really, this calculation is maybe a little more designed for a data review part, where you're really only looking for the top very strange values. And the outliers calculator here might find some more of them. Really a good way to just find strange values that you should check out and kind of confirm. So those are really the three big tools for the data confirmation step. The one last point I had, looking back at our slide, was kind of the recommendation about deciding an acceptable range of values kind of before you go and take that assessment. And so some of that might be within your head, within the researcher's head, to say, we're going to go out and take this rating on the disease on the leaf, and I sure would be surprised if I got over 50%. And looking at those values, they're all about under 50%. And so if you had had that kind of goal in mind, then when you came across that 65, that certainly would be noteworthy to you, and that would have been a cue while you're still in the field to maybe take a little bit more documentation on that and snap a picture and things like that. There's also a little bit of range checking within ARM as well. I just wanted to point out some of those that might be helpful as you're entering in the data. And so you can do that in like the rating unit. So I'm just going to make kind of an empty data column here. And if you choose something like a percent, then when you're typing in the values, if you were to make a typo here and type something that's outside the range of 0 to 100, then there'll actually be a dialog that pops up. And so this would be kind of helpful for catching that 120 that we started with, that problem that we had started with originally. When you're typing it in, ARM will pop up and say, that doesn't make sense because my rating unit is set to percent. I don't think this 110 really is a valid thing to type in. So it'll catch that. It gives you a nice opportunity to change and say, yep, that's what I meant was 10. You can do something similar as well. If I go to the ARM action codes field, there are other rating limits that you can use as well. So there is, if it's 0 to 12, 0 to 10, 1 to 7, 1 to 5, there's a variety of different ones depending on kind of common uses. If you have one that you use that isn't in the list, let us know and we can certainly add it. There is, if I scroll down, I believe there's another section for the EPO rating scales. And so these are kind of calculated columns. If you're doing the rating scales, you can do some calculations with those as well. Just so you know, those are there. Also percent incidence for the EPO scales from 1 to 5 to 1 to 10, depending on the type of scale that you might be using. Kind of check out this list to see what kind of calculations you can do. You can kind of automatically calculate a percent incidence from subsamples even, things like that. We won't dive too much into those calculations. That's a little bit outside of the data confirmation step. But yeah, and there's a question here on this, if it will catch from if you copy from Excel. And I do believe so. Let me just double check. So if I have 9, 12, and 112, I'll do a poor example of not including plot numbers. I'll say yes, just paste them right in. Guess it didn't catch that. Now, trying to remember though if in the validation will it trigger? No. So I guess when I put in that rating unit, if you already had values in, then that will check. I'm a little surprised it didn't do it when we pasted. Maybe because I didn't have plot numbers. Let me try. One more thing here. So if you include plot numbers, which is definitely a recommended thing to do with your data, then ARM will be sure to find and put those values in where that plot number resides instead of just blindly in order. And I want to, yes, add that piece of information into this column. No, I guess it's not catching that with the paste. A good question. It wouldn't be the worst thing that maybe after you paste, there is an action code, in this case for that percent, you could apply that then, and that would trigger it. So, and just to point out, there are two options here. So it's continuing to yell at me. You need to change that 112 and make it valid. If instead you realize, well, I don't want to mark that as P, it shouldn't be, I actually need to allow it to be greater than 100, then you press cancel. And that'll let you go back to this column, and now you can take that validation off. And of course, now I still have my rating unit as percent. So I would need to take that off as well if that was very, very valid. So those are two good places for just checking as you're entering values in. But it's not a bad idea, just in that general sense of as you're preparing for an assessment, to have in mind what would be a normal expectation for the values you're going to see, because that's a good mental trigger then to maybe document a little bit more if you see something outside of those ranges for doing that. So that's really what I have today for showing those tools. There are some questions here. I want to make sure I've covered all of them. So I'm scrolling a little bit, and I want to kind of open the floor up for if anyone else has some questions. I appreciate all the questions throughout here. That's really good to as we're covering topics. But if there's something else you're holding on to, feel free to let it fly. Making sure we covered that. When we have an outlier, what to do with it. Yep, and the outliers did update, or when we marked as damaged, the tools did update. And I guess one thing I could show just real quickly, Dan's point about that Yates formula. My screen's a little off here. Let me change that. For a little bit related to the analysis, but in the print report section, when you're going to do that analysis there, the AOV means table, on the general summary, the very first option there is your missing data estimates. So Dan had mentioned that Yates is a technique that adjusts for missing data. And alternatively, you could just use the average. So that really uses the existing plots that you have. It'll use the average of that in the calculation. That really does only apply for your traditional analysis method. We can dive into more of those specifics too with the reporting session as well. But just wanted to, since we talked about it a little bit, point out that location. So a question here about the assessment map. Let me just draw that for us all while we take a look at that. So, color by current treatment, but kind of reorganized by treatment. So I guess thinking spatially then, so instead of just drawing each of them where they exist on the map, reorganizing them to see them next to each other? Is that kind of the thought there, Tom, that you're imagining? One way to condense that a little bit, if you're just thinking about all that space there, if you turn off that true scale, it might be a little easier to get those two together. I think, you know, a lot of the value is that spatial effect to it, but yeah, to be able to compare those values across replicates, I think is kind of probably what you're thinking of, is really just to compare each of them. You know, you could always sort your data by treatment, so at least then you have those values next to each other. And yeah, you don't quite have that nice color scale to it, like you would if you had the map. So yeah, that would be an interesting view on the assessment map, instead of using that trial map, and instead really just highlight the single treatment, or maybe you don't even need that map then, and you could just color code, kind of like you can do it in Excel. You can have that color range. Maybe to do that in ARM would be kind of interesting. Yeah, kind of like that idea. Yeah, so great questions, great ideas. It's good to hear ideas as well. You know, we really here at GDM, we don't do any research. Probably kind of obvious in some of the examples I give, but we really listen to you guys who are using the software as to the tools you need and what would be useful. So especially in sessions like this, it's great to hear questions. In part to make sure that you guys are understanding what we're trying to show, but also it kind of tells us a little bit of stuff too of, well, maybe this component isn't as obvious as we thought, or maybe we could change the interface a little bit to make it easier, or maybe we need a different tool to make that work better. So we appreciate those questions and comments and ideas. So. I guess with that, we have just a couple more minutes for the top of the hour. If there were any other questions, I can hang on the line, but otherwise, I appreciate all of your guys' time, and we'll reconvene again next week. So we did Monday, Tuesday this week. We'll do the same thing next week, same time for the data. Next Monday will be kind of that data review, prepping the data for the analysis. And then the final session will be about that AOV report, some of the options related to the analysis, some kind of tips, common questions we get about that analysis, all kind of rolled into one session there. So thanks again, everyone. Some of you certainly later than others in the day. I appreciate those staying up or getting up really early, depending on where it is. It's a great to have that challenge with the worldwide use. It's great that everyone can join us, and hopefully the recording will be a value for those who can't. So we'll be talking to you again hopefully next week. Thank you, everybody.